Welcome to Jump Teach Tech on lesson 2 on shear transformation. If you have not watched the previous lesson, kindly make sure that you do in order for you to understand the current lesson. Today, we'll be describing a shear transformation given an object and its image points. So example 1, a quadrilateral ABCD with coordinates A10, B40, C44 and D14 is mapped onto A'10, B'40, C'104 and D'74. Questions that we're supposed to answer from this one is that we need to draw a quadrilateral ABCD with its image on the same axis. Question 2, calculate the shear factor, which is the main focus of this current lesson. Describe a transformation that maps ABCD to its image. So, start by drawing the x-axis and the y-axis. So, we have 1, 0, 4, 0 as point B, point C, 4, 4, point D, 1, 4. So we join the image points. We have 1, 0 as A prime. Point A remains unmoved. Point B, 4, 0 also on the same spot. So we can easily identify the invariant line because the points on the invariant line remain unmoved under shear transformation. Point C prime, 10, 4, that is C prime. Point D prime, 7, 4, that is D prime. Then we join. So we can easily tell that this is a shear transformation with x-axis as the invariant line, simply because the points on the invariant line remain unmoved. And the second point is that points on the object move in a direction that is parallel to the invariant line. You can see that point C is moving in a direction that is parallel to the invariant line. So in this case, so x-axis as the invariant line. Calculate the shear factor. So this is x-axis invariant, and to calculate the shear factor when the invariant line is the x-axis, we use this particular formula. We say that k equal to x2 minus x1 over y minus n, where n is the invariant line. N is the invariant line. And remember, when it is x-axis invariance, it's only the values of x which are shifting. The points that are not on the invariant line must move in a direction that is parallel to the invariant line. And in this case, these points are moving in this direction, where you can see clearly that it's only x values that are changing. Y values are not changing because Y values are supposed to change when you move either upwards or downwards. But when you move left or right of the x-axis, then the values of x are the ones that are changing. That's why we do x2 minus x1 all over y minus n, where n is the invariant line. So practically, let me choose point D that is moving in a direction that is parallel to the x-axis. So we say equal to x2 is 7 minus 1 all over the value of y, which is 4, minus 0, simply because the invariant line in this case is the x-axis, or y equal to 0. So which is 6 over 4, and we end up getting 1.5 as the shear factor. The matrix of transformation when the x-axis is the invariant line is given as 1, 0, k, 1. So substituting the value that we have just got of 1.5, we say that in this case that the matrix of transformation is 1, 0, 1.5, 1. If they had asked us to get the matrix of transformation, that is the case. Describe a transformation that maps ABCD to its image. The transformation is a shear of scale factor 1.5 with a line y equal to 0 or x-axis as the invariant line, and D14 mapped to D'74. Example 2. And our shear with the x-axis invariant C32 is mapped onto C'72. Find the shear factor. Under x-axis invariant, shear factor K is calculated as x2 minus x1 all over y minus n, where n is the invariant line. In this case, the invariant line is the x-axis, which is also known as y equal to 0. And we are doing x2 minus x1 simply because under the x-axis invariant, the points are supposed to shift in a direction that is parallel to the invariant line, which is the x-axis. So looking at the 2 points, we have the x1 as 3, x2 as 7. It's only the values of x that are shifting, but the values of y remain constant under the 2 points C to C prime. So we say it is 7 minus 3 all over 2 minus 0, because the x-axis is 0. We end up getting equal to 4 all over 2, and the shear factor is equals to 2. Example 3. A rectangle ABCD with vertices A00, B30, C32, and D02 undergoes a shear transformation with points B30 mapped to B3, -4. Draw the object and its image on the same axis, given that the line x equal to 0 is the invariant line. Line x equal to 0 is y-axis, so this is y-axis invariant. Start by drawing the Cartesian plane. Point A is 0, 0, point B 30, point C 32, point D 02. We've been told that the figure undergoes a shear transformation with points B30 being mapped to B prime, 3, -4. This is where we have B prime. Draw the object and its image on the same axis, given that the line x is equal to 0 is the invariant line, which is also y-axis. So for us to get the point C prime, because what we require is C prime, we need to calculate first the shear factor. The shear factor is equals to, for the y-axis invariant, is y2 minus y1 over x minus n, where n is the invariant line. We are doing this because it's only values of y that are supposed to be changing, because the shear is y-axis invariant. They are supposed to be moving in a direction that is parallel to a fixed line that we're calling the invariant line. So K equal to y2 is -4 minus y1 0 divided by the value of x in both cases is 3 minus the invariant line, which is 0, and we end up getting -4 over 3, and that is the shear factor. So to get the second value of y, we say -4 over 3 is equal to y2 minus y1, which is the value of y-axis coordinate on the c, which is -2 over 3 minus 0, we do cross multiplication and we get y being minus 2 being equated to negative 4 over 3 times 3. y2 minus 2 is equals to minus 4. So y2 is equals to negative 4 plus 2, which is equals to 2, negative 2. So C prime has coordinate, C prime has coordinate 3, negative 2. So we spot negative 2, 3, negative 2. That's where C prime will be. And the points that are on the invariant line remain unmoved. They don't shift positions. So we'll connect A to B prime. This is where A prime will be. D to C, D to C, D to C, and lastly B to C, that way. So this is the image of the rectangle and our shear transformation. So within the explanation, we will say that this is a shear transformation with scale factor, shear factor as negative 3 over 4, and x equal to 0 as the invariant line, with point C 3,2 being mapped to C prime 3 negative 2. Example 4. A point R 5,8 is mapped onto R prime 5,23 by a transformation shear y-axis invariant. Find the object coordinates w, x, y of w prime 3, 4 under the same transformation. For the y-axis invariance, K, which is our shear factor, is given by y2 minus y1 over x minus n, where n is the invariant line. So K equal to y2 23 minus y1 8 over x, which is 5, minus the invariant line, y-axis invariant, is x equal to 0 minus 0. So we end up getting 15 over 5, which is equal to 3. So we are looking for y2 after getting the shear factor. Find the object coordinates xy of w prime 3, 4 under the same transformation. So 3 equal to y2, which is 4, minus y1 divided by x, which is 3, minus 0. Y-axis is the invariant line. We end up having 3 times 3 equal to 4 minus y1. You take y to this side, the other one to the other side. We have y1 being equated to 4 minus 9. So y1 is equals to negative 5. The coordinate xy, so w 3 negative 5. This is the object point that is supposed to be transformed by the same shear in order for us to get 3, 4. Thank you for watching. This is the end of lesson 2. Kindly like, share, and subscribe for more tutorials.